That reaction was not expected.
So we were supposed to check if it was true?
No, I said,
Oh.
don't worry, I'm not going to take points off.
Oh, okay. That's why I was finding out.
But just like on that one handout, that when the handout for the confidence intervals for percentages, and I said check NP and NQ, I might just say check NP and NQ. You have to understand what that means. I'm like, oh, it means to check to see if it's normal, greater than 5, right?
Yeah.
Yeah. Okay, so no questions from homework stuff? Not yet, all right. All right. So, we finished the stuff about confidence intervals now. We've done confidence interval for the mean, confidence interval for the percentage. When do we have to use t-scores?
For the sample. When you're using a sample deviation.
Exactly. The t-score chart, how high number-wise does the t-score chart go? What do I mean by that? Does it stop? It goes all the way to large, which is arbitrary, right? So it goes up to the 200s, 500s. Are you with me? So I don't know where this is coming from, but on some of the homework, somebody was telling me that you use t-scores because the sample is less than 30 or something. That's not true, right? In fact, if the sample size is less than 30, why might that be problematic if I want to do anything? Because that by itself is not good enough to say it's normal, right? So some of the problems in the homework, I think at least one problem doesn't say anything they should, but some of them say assume that the underlying distribution is normal, which means you don't have to take 30. You can take however, you can take 1, and we've done that before. 1 person, right? All right, everybody's slowly coming back. Okay. All right, so that's the confidence intervals. So there's no question about those. We'll see today. We'll see after I grade these, if there should have been. We're getting into now a fundamental flaw that confidence intervals have is, what do I build a confidence interval off of? What do I do to start a confidence interval? What do I have to be given to create a confidence interval? Where do I start and go up and down? What do I start at? The mean, like what kind of mean? Sample mean, or the sample percentage. You guys with me? So and sample mean and sample percentage, I would almost put a lot of money on them being wrong, right? And that's the whole kind of idea of a confidence interval, is to say, I know this is wrong, so let me cover my ass by going and saying it's actually somewhere in here. Are you guys kind of with me?
Yeah.
But that is a fundamental flaw. That's why we don't use confidence intervals for official tests of claims. So that's what we're going to get into now, is how to really test a claim. So I did point out that a confidence interval can give you an idea of if a claim is right or not. Right? Like the thing about the voters, and some of them lied. So they're like, yeah, I voted. And we're like, no, it actually was 49%. So since that wasn't in our confidence interval, it wasn't evidence that it could be that. So it was evidence that they were lying, right? It wouldn't be something I could write an article about. I would actually need to go through a different process to really test it. But that's kind of like first blush evidence, right? I think that might be it. Let me go do the real full test. Okay, all right. Okay, so we're going to slowly step into this. When I learned this process, there were 8 steps to it. Oh my God. So I've shortened it down to 5, right? So you're welcome. And I'm going to try to make sense of the idea behind it first, and then we're going to go through each step and explain why each step is necessary. This is what we're going to try to do today. Okay, so here's something that could happen in the real world. Let's say some dude invents a car, and he says, my car gets 35 miles per gallon. Right? That's the claim. That's what he puts in his commercials, right? So he says, okay, the claim is car gets 35 miles per gallon. All right? Yes, ma'am. So this is, you guys, I got my old chapters in my head. Chapter 9. Chapter 8 is the one about confidence intervals. We're done with that.
This is 9.1.
This is 9. This is chapter 9, basically. Yeah. Yeah. So this is the claim, and we think that it's not 35 miles per gallon. We think that's wrong. So it could be higher or lower. We just think it's not 35, right? So this is how parts of statistics work. We go out to take a sample to get a feel for what's really going on, but sometimes that's spurred by some idea we have. For example, I could create a drug that I think works quicker than some other drug. Well, how do I prove that? I've got to do the process we're about to create. I've got to show evidence that my claim is right. My claim is my drug works faster than this. You got a headache? Well, my drug cuts it in half the time that your headache will go away once you take it. You guys kind of with me? So this is the process you have to go through to kind of show evidence for that being true. All right. So this is the claim we're working right now. How would we test this claim? If I said, okay, let me test this claim. This is wrong. But if I approach one, which is going to be wrong, would be I take one of his cars out, and I drive around for a while, and I get 31 miles per gallon in that car. You guys kind of with me?
Yeah.
All right. Why is that not good enough to say that his claim is wrong? Yeah, one car on its own. Who knows? How was I driving? What kind of gas did I put in there? All kinds of things affect gas mileage. So that's not good enough evidence. Or maybe that one car, no matter how well you design a car, every now and again you get a car that's just a lemon in some way. Something doesn't work quite right in its systems. Are you guys kind of with me? So maybe randomly I got a car that was not up to snuff. Are you kind of with me? A little bit? So one element of a population could be very far from the average. That could happen, right? One thing. Just like we said before, one person being this tall, that could happen. But if I see 30 people this tall, that is evidence that something is going on, right? They're doing a reshoot of Wizard of Oz. Something's happening, right? I'd be really worried for that just to randomly happen, right? Okay, so a better approach. Why do you say that? I like it. So we want to pick a sample size large enough so that we know the sample means are going to be normally distributed. So it's got to be at least, so let's make it a little bit bigger, even just to cover our ass a little bit better. 60, I love it. So we probably get some friends, and we take 60 cars out. And let's say this time we do get an average of 31 miles a gallon. So now I feel like it's still not good enough to just say that's enough evidence. Because what is it about statistics that tells me, all right, so what am I trying to show here? What do I really want to have happen? If I really believe my claim that it's not 35, what do I hope happens? If I see 60 cars with a gas mileage of 34.7, do I feel good about my claim? No. What do I think? I think it isn't 35. If it is 35, where should a sample's average be? If the average really is 35, any sample I take, their average gas mileage should be close to 35. Kick ass. So if I do take 60 cars out and I got 34.7, do you think that's evidence that the car's gas mileage is wrong? No. That's pretty damn close. So the whole idea here, I still can't say for sure, because what is it that tells me how close data points are? The number of standard deviations, which is also known as the z-score, kick ass. So somewhere I need to see, what I really want to find is, if I think this average is wrong, I want to find a sample whose average is so far away from this that there's no way this could be right, or there's very low chance this could be right. How do you guys feel about that? So this chapter is where we really put a lot of things together all at once that we've been studying. Right? They all kind of come together. Cool. I like it. So some things I'm missing here right now. What am I missing to calculate a z-score right now? What am I missing? No, I see what you're doing. So I'm not constructing a confidence interval. I just want to get a z-score. How do I get it? What's the formula for z-score? All right, standard deviation is in it. What's the formula for z-score? Something minus something. Look at it. There's a minus sign in. That's right. There's a standard deviation in there somewhere.
The mean minus the standard deviation. The mean.
Has it been that long since we did this?
Mean minus. Oh, x over standard deviation.
I like it. So this is the general standard. This is the general z-score formula. Now, what's kind of wrong with this formula, considering how I got my data? What did I do to get here? What did I do to get this number? How did I get 31 miles a gallon? What did I do to get there? Yeah, took 60 cars. 60 is the... I took a sample. Oh, shit. And I'm talking about means. I took a sample. Talk about means. So what's supposed to happen? It's question. When I take a sample and I talk about the sample means, what changes?
Standard deviation.
The standard deviation changes. So the formula will actually be this guy here. Right? And actually I'm talking about sample means now. I like it. So it's basically the same z-score formula. I think a while back I told you the z-score formula actually never changes. It's always the data point I'm interested in minus the middle of the data divided by the standard deviation. And if I'm talking about groups of size 60, I got to use the correct standard deviation. How we doing so far? A little bit. All right. So what I'm missing then is I don't know what the standard deviation of the population is. So let's say we know from previous studies, we'll say we know that standard deviation for the whole population, let's say, is 7 miles per gallon. Just to come up with something, right? Let me stop there for a second. So what this means is the standard deviation for the population of all cars, their gas mileage, 7, we'll go with 7. I tried finding out, I don't think anybody told me anywhere on any website I could find what the real standard deviation is, so we'll say it's 7. All right, let me stop there for a second. So now, how do I calculate the z-score then? What's x bar? What is 60? What's 60? It's the number. So 60 is n. I like it. N is 60. What's my sample mean? 31. All right. And how do I make my new standard deviation? The one for groups of size 60. It's the old one divided by square root of n. Kick ass. So it's because the new standard deviation, the one for groups of size 60, is 7 divided by
60. No, it's a square root.
square root of 60. There it is. So somebody help me out. What's that? .904? All right. Crowdsourced work. I like it. Let me stop for a second. I really want to make sure. The thing about statistics you guys have certainly learned is you always have ideas and then you have formulas and computations. So as you work through a computation, as you work through working with a formula, you sometimes forget why you're doing what you're doing. I really want this to make sense. If I want to show evidence that this guy, he thinks the mean is here, I'm like, no, you're wrong. I have to show that a sample I take is so far away, because any sample I take, if that really is the mean, you guys told me it should be close to that. And the idea of close is controlled by z-scores, right? I like it. In fact, right now, we're about to refine this definition, but where do we say unusual starts? 2 standard deviations away, right? And we're going to actually kind of adjust that in this chapter now. That could change depending on the situation, right? If I'm talking about a nuclear power plant exploding, I probably want to be more conservative. I don't want to wait. I'm not worried yet. The z-score is only 1.97. I think I'm going to get off my ass and go check, right? The minute the needle starts to move a little, I'm like, shit, let me check. You guys kind of get me. I want to think of unusual as something more conservative in some situations, like nuclear explosions, right, for example. So, yes?
So it uses z-score with the new standard deviation for groups?
Good, because where did I get my 31? What's that represent? The average of a group of 60, right? So I want to compare that to what all groups of 60 would be. And all groups of 60 would have an average of 35 if this was the right average. So here's the other thing about this. Remember I said confidence intervals are kind of not the best because they build themselves off of a most likely incorrect thing, like the sample mean or the sample percentage. So what hypothesis tests do, maybe this language sounds familiar, I think it's 35. Oh yeah? Well, assuming it's 35, look what I just did, right? So we're going to assume that that really is the average. So if that really is the average, my sample should be close to it. If I get a sample that is not close to it, that's evidence that this is not the right mean. So let me say that again. This guy thinks his distribution looks like this. Cool. I think maybe it looks like this. His mean is in the wrong place, right? Or maybe even up there. So if I find a sample that's like way down there, is that likely to happen? If that's the real mean, where should I be? If that's the real mean, where should my sample show up? In here. So if I get one way the hell down there, it's more likely that the distribution is really drawn, then that would be closer to the middle. The distribution really is further down. The mean really is less. So it's more likely then that the mean is in the wrong place than I just happened to pick a bunch of cars that didn't quite work right. All right. Now again, this is going to take several iterations of explaining what it is we're doing and why and what it means until it really starts to sink into the brain. But I'm hoping you guys kind of get that. I've been sort of getting us ready for this the whole semester, I don't know if you've noticed. All right. So can we calculate our z-score now? Hell yeah. So what do we get for this z-score? We get, what's my mean is 31. We're assuming the actual mean to be 35 divided by 0.904. I get 4.449. So I have
424.
424?
4.424.
4.24?
4.4.
424, there it is. Someday I'll hear it right. Now just look at that z-score. What does that z-score scream at you? Is that close to 35? What does a z-score mean by itself? What does that z-score tell you? My data point is... What does that z-score tell you? That's that question I keep asking you. What's the z-score tell you? It tells you the number of... Good. So my data point, 31, is 4.424 standard deviations away from the supposed mean. Is that close?
No.
Hell no. In fact, we just said we were assuming unusual to start outside of 2 standard deviations, right? That's what we were doing before. All right, let me make sure you guys, I really want this to make sense. That is really far away, right? That is really far away from the supposed mean. So what's more likely? That I just happened to get a bunch of cars. What's more likely? The real middle is 35, and I just happen to get a bunch of cars down there. 60 freaking cars that all weren't quite working right. Or is it more likely that the actual mean is not 35? That's more likely. Is there a chance that I'm wrong? Of course there is. There always is. Right? Because that's what I love about stats. It's very honest. Oh shit, that could be wrong. Alright, I like it. Maybe. So if I would have gotten a z-score of like negative 1.2 here, is that very far away? No, that would not have been evidence that the mean is in the wrong place. That appeared in about the right place. If 35 was the mean, that was in a place to say, it looks like 35 could be the mean. It's not far enough away to say it wasn't. Okay, I like it. All right, so we're working our way towards some more concrete stuff here, but I got to get the ideas kind of down there. Okay. So when you're given a claim, here's the first couple steps to go through. Let me see. So while we were working that out, we knew it was normal because we made the sample large enough. So one step in my whole hypothesis test, 1 out of 5 steps is going to be, are you going to use z-scores, t-scores, or nothing? Because if I say I take 11 people and I want you to do a test on a claim of their IQ or whatever, is that good enough to do anything? 11 people. No, if I don't say it's normal, I can't do anything. I can't use the z-score chart to get the areas, to get the z-score, so I can't do that. So somehow they got to tell me, they got to say it's normal, they got to give me a large enough sample, some way of knowing it's normal enough, right? So one step is going to be that. The very first step is just going to be, what's my claim? So let's do this. Let's say that somebody claims, let's see. Let's say that I claim that the... Actually, let me ask you guys, what's the average price of gas right now? I haven't filled up in a while. What is it? I love it. It kind of tells me, some areas, I'm like, I never want to go to Carmel Valley, for example. I always look there, and it's like, $1 more than somewhere else. Now, screw that, right? So what do you say, like $2.75? Gas price, let's say the claim is it's $2.75. Now, somebody else tell me, how do you feel about that? Do you think it's everybody agree it's $2.75 right now? Does somebody feel differently? Everybody feels about $2.75? I don't get any disagreement?
Here, I'm checking.
Oh, you're checking. All right, that's fine. All right, so let's say that's our claim. If we want to show that we want to kind of show evidence that that's not false, I want to see if I can reject this. If I can do a test and I reject this, I'm like, oh shit, maybe I'm wrong. So if that's my claim, mu equals 2.75, what's kind of like the opposite of that? What's the counterclaim?
It's not equal.
Not equal to, I love it. All right, let me stop there. So obviously, now let me make sure you understand. The first step is going to include both sides of the argument. And there's always two sides to an argument the minute you have an opinion. We know this all too well, right? It's just what I call these two guys that we got to get used to. I call this one HO. We're going to love this. This is the null hypothesis. Okay, that's the official name of it. I don't know if you guys realize that. Anybody know what that's normally called? If you took some chemistry or something, you see a little O and it's like H naught. Yeah. That's how you read it. Is that a few of you guys have heard it before? H sub O. I'm just going to call it, unfortunately, the HO. So this is the HO. This is the null hypothesis. This is like our original hypothesis that we're going to test. We're going to test it. We're going to see if an alternate hypothesis is true. So we call this one the alternate hypothesis. The high, exactly. So we got the highs and the hoes. Exactly. That normally grabs your attention a little bit. Alright, so step one is just going to be what's your claim and then what's the opposite of that. That's really the first step. The key is, here's the thing. Which one of these statements can I show evidence for? This is where things get a little weird. If I thought that the average was 275 and I go out and take a sample and I get 275 in my sample, is that evidence that it is 275? Think about it. If I take a sample and I get a sample mean, what's almost certainly true about that sample mean? How does it relate to the real mean?
It's probably off by a little.
It's close, but more than likely it's going to be off somehow, right? So anytime I take a sample, I can never prove that the real mean equals something. I can never do that with a sample. But all day long, like we just did, I could show evidence that it doesn't equal something. If I think it's 275 and I go take a sample of 200 freaking gas stations and I get $3, right? We got to do the test really, but I feel pretty good that that's probably going to be evidence that it ain't 275, right? You guys get a feel for that? So I can show evidence against something, like a counterexample, but I can never show full evidence that this equals this through a sample. Are you guys kind of with me? Now, if I took the whole damn population, I know what I can just, there it is, I know what it is. But what do we normally work with? Samples, right? I can never prove the mean is something through a sample. Okay. So let me ask you this. So we're going to assume that 275 is the mean. What would show evidence for this? What would show evidence that it isn't 275? Where would a sample fall? Like, if I had a sample that was right here, well, how do you feel about that? How do you mean it's good? Does it show that it's not 275? No. So where would a sample have to fall to show that it isn't 275 more than likely? Really far away, which direction? Either direction, I love it, because not equal to either direction. So how many tail tests is this? How many tails did I just make? 2. As you can imagine, now we're finally seeing why that one tail option is on there, because if I said that my claim was, I think it's less than 275, how many tails would that be? 1. There's only one direction I can go. I want my sample to show up down there. So then it would be a one-tail test. That's where I would look on the t-score chart. All right, I like it. Maybe the mysteries have been solved. Okay. So this is a 2-tail test. Kick ass. I like it. The second step would be that step where I said, can we use z-scores, t-scores, or nothing? And then I have to know a little bit about the situation, right? Z, t, or nothing. So what's got to be true here if I want to use z-scores? There's 2 things that have to be true if I want to use z-scores. What's got to be true?
You have to be using a...
And what tells me that it's normal?
Standard distribution.
So one thing, it's got to be normal. And what tells me it's normal? N greater than 30, or they just say it. And you've seen that in the homework, right? They just say so. It's normal. Okay. And for z-scores, what else do I need to be true to use a z-score? Population standard deviation is known. Because why were t-scores invented?
To use a sample standard deviation.
Exactly. T-scores were invented to cover our ass for when we don't know the population standard deviation, right? Is that cool? What is this? Sigma? No. So for t-scores, what would have to be true in order to use a t-score?
Has to be normal.
2 things. Still has to be normal. Still has to be normal. Either n's big enough or they told me. And secondly, like you just said, sigma is
The sample.
not known, right? We only have S. I like it. Cool. Okay, maybe. So here's where things get interesting. So like I said before this chapter, we assumed that unusual started at 2 standard deviations away. But now we see there's reasons why I might want to feel differently about that, right? Maybe I don't want to let it change so much. So maybe I want to make unusual start at 1.645. So the minute it gets past that, I'm like, oh shit, let me go check the reactor, right? I don't want to attract Godzilla. Yes?
Under G-scores, number 2, what is that last one?
Oh, sorry. It's actually 2. Only have S. We only have the sample standard deviation. I like it. So this third step is going to be related to defining where unusual starts. So here's how we have to... All right. Does somebody remember what the letter alpha represented? We talked about alpha. If I said alpha is 0.01, has something to do with confidence interval. So if I wanted to be 99% confident, what would alpha be? So if I want to be 99% confident, alpha would be 0.01. So that's kind of related to a 99% confidence interval in a way. Are you kind of with me? So if I wanted to define my unusual to start at the z-scores that relate to 99% confidence interval, I would let alpha be 0.01, where that is what would be given to me. So this, let's see if I can get this makes sense. So if I think the mean is 275, and I get a sample that's way out here, for alpha equal to 0.01, the probability, so for 0.01, what percentage is inside here? 99%, 11. What is the chances then? What are the chances that a sample would show up outside of there? If there's 99% in there, what's the chances that it shows up outside of there? 1%. So this is kind of like, what's more likely then? I just happened to get a sample that was that far away from the mean, that I was way out here in the 1% area, right? Or is it more likely that the mean is wrong? It's more likely the mean is wrong, because just randomly happening to get a sample that's way out there would only occur 1% of the time. So what's more likely then is that's not the real mean. The real mean maybe in this case is higher somewhere. Maybe. Do you see how I just said something I said earlier? I'm going to keep doing that, because that idea is central to hypothesis tests, and we're going to keep attacking you with it. So this step then, somebody help me out. What would these z-scores be? Some of you might even remember. Don't be scared if you start remembering these numbers. 2575, yeah. I like it. So this third step would be, they're going to give me this. That's